Well, hey guys, thanks for checking out Next Level Carpentry, where I'm going to unbox and review this amazing P2 55 watt desktop laser from xTool and fire it up for a couple quick projects here in the shop. Rest assured, I'm not shifting my focus away from traditional woodworking here on the channel and towards high-tech laser production, but I am expanding my horizons and my skill set by adopting the cutting-edge technology that this laser is capable of. And FYI, xTool shipped this P2 desktop laser to me for my honest review and opinion, but they're not sponsoring this video, so I'm not obligated to sugarcoat my reactions or my opinions as I unbox the machine and put it to use. As many viewers know, I'm pretty old school when it comes to woodworking, so the whole world of laser engraving and cutting is pretty far outside my comfort zone. But I love learning new things, so I'm excited to introduce like-minded viewers in the Next Level Carpentry audience to some possibilities that a next level laser like this can accomplish. Because I'm more of a digital troglodyte than the typical digital native that reviews the latest technology like this laser, I decided to just do a routine unboxing, and I'll leave discussion of specifications and in-depth particulars of laser type, setup, and startup to other reviewers on YouTube who are far more capable and qualified than I'll ever be when it comes to high-tech equipment like this. As you could tell by the lift card I used in the introduction to this video, the P2 desktop laser is a robust machine with around 100 pounds of gravity built into it, which means it takes muscle, logistics, and a bit of determination to unbox it. Even though the carton had a few bruises from shipping, there's sufficient packing material to prevent damage to the outside of this new P2 CO2 laser. With the carton and all exterior packing material removed, you can see just how impressive this xTool P2 desktop laser is and get an idea why I chose to review this brand and this model here at Next Level Carpentry. As I'm sure you're aware by now, the xTool P2 is classified as a desktop laser, but because I don't have a suitable desktop anywhere in the shop to put it on, I'm going to make a custom mobile base for it to use here in the shop, starting right here and right now. Welded steel is my design of choice for custom mobile bases, so I set about measuring and cutting 1-inch medium gauge square tube for the main framework. This amazing 15-inch dry cut saw from Evolution Tools makes quick work of precisely slicing square tube, flat plate, and rectangular tube with square and angled cuts for the various pieces parts for this custom cart configuration. If you've never seen this type of saw in action before, it really is just as unbelievable as it looks here. Once I have all the pieces cut to length and shape, I use an 80 grit flap disc on an angle grinder to remove the very small burrs left behind by the sharp blade on the dry cut saw. With burrs removed, I dry fit the top framework that will support the P2 laser. When I'm satisfied with how everything fits, I square it up and tack weld the frame perimeter together and then complete the welds and dress them to my satisfaction with an abrasive wheel on the same angle grinder. After finishing welds on the perimeter, I used a sharp Sharpie marker to lay out holes for the laser's feet and locations for the rectangular support tubes so they line up with the asymmetric location of the machine's feet. To aid in drilling the rectangular tube, I use a sharp center punch to define the exact center point for these 1¼ inch diameter holes. Then it's over to the drill press, where I use a slow speed and a good shot of cutting oil to drill holes through the top face of these tubes. With the holes drilled and oil removed, I position the support tubes in the perimeter frame and tack them in place, using center lines for alignment to make sure they end up in the right location. I assemble the lower perimeter frame in the same manner as the top one and, once complete, stand top and bottom frames on end, position and align angled leg tubes, then tack weld the first 2 legs in place. Next, I flip the assembly over and lather, rinse, repeat on the other end of the cart. Once all the joints are tack welded, I do a careful cross-taping sequence to make sure the cart is square in all directions, and then finish welding all the joints. I welded flat steel plates into the 4 bottom corners for attaching casters to the cart later, and, using a very cool flat angle grinder, do final grinding and flap wheel dressing on the welds on difficult inside corner joints. Once all the sparks have settled and cooled, I go about painting the frame. First, I apply a couple coats of gray primer, scuff it to remove nibs and burrs, and then finish up with a thorough wet coat of satin sheen black hammered finish spray paint to give the cart a classy industrial look and feel. The only bit of carpentry involved in making the cart is assembling and installing a simple H-assembly that serves as a framework for holding drawer hardware. The assembly is made using pocket screws to hold it all together. Next, I attached full extension self-closing drawer glides to the H-frame in a very basic but functional design that adds a touch of class to the whole cart, in my humble opinion. Final assembly of the cart starts by flipping it upside down and bolting on 4 casters, 2 fixed wheels, and 2 swiveling locking ones on opposite ends of the cart. After all 4 wheels are securely bolted on, the cart gets flipped again and taken for a quick test drive around the shop floor. Now I can clamp the H-frame in place and secure it with screws driven down through pre-drilled clearance holes in the top frame of the cart. I built 2 identical drawers of 5/8 inch thick white melamine faced particle board off camera. Fronts for the drawers were made from the same ash veneer 3/4 inch plywood as the H-frame and get screwed onto the fronts of the drawers at this time. It's always exciting at this stage of a project where drawers are slipped into glides and the whole thing comes together, almost like following a plan or something. Installing drawers completes the build, so it's time to employ a little more Egyptian engineering that involves the lift cart, a thin sheet of scrap material, and more muscle to place the heavy P2 laser into permanent position on its new custom mobile cart. Well then, now that I've got that little detail taken care of, and I actually have a functional desktop substitute for the laser here in the Next Level Carpentry shop, I'm going to get to work removing the rest of the internal packing so that I can get this machine set up and ready to use. And as I said before, I'm going to leave the particulars of the setup to other content producers on YouTube who are much better at tasks like cleaning and aligning the mirrors for the laser and adding antifreeze to the laser chamber underneath the rear hood of the machine. So feel free to take a break, grab a bucket of popcorn, and I'll see you back here in the shop when I've got this machine all plugged in, set up, hooked up, and ready to fire up and start making smoke on an engraving project or two to show off a few of the machine's capabilities and to prove it was worthwhile investing the time for making a portable cart for the machine. So it's a good fit here in the Next Level Carpentry shop with all the other equipment that I use on a daily basis. This will only come as a surprise to viewers that don't know me very well, but I've decided to include the rest of the unpacking and unboxing just to have it on the video record so you can see everything that comes with the P2 laser and emphasize the point of how well this is packed, which I think is a good thing based on some of the stories, some of the delivery stories that I hear anymore for the way things get shipped. But I'll say again, I'm not going to include all the details of the setup for hooking up the cords, adding antifreeze, etc. I'll just leave that to other content producers or the xTool website itself for those details. And as you can see, one of the first things on the top here is a stack of materials, sample materials for various engraving and cutting tasks. Zooming in, you can see the power cord, material hold-down clamps and a screwdriver, a USB cable, and a couple screws for attachments which get put in the drawer here for when I set the machine up. Here's the funnel for filling the antifreeze, and over in this side under another layer of dense foam is the exhaust pipe for fumes that come out of the machine while it's cutting and engraving. And this bottle is what I dug in here for in the first place, and it's the antifreeze that gets diluted and mixed and poured into the container on the laser to keep the laser tube cool. And that's primarily what I was after while unpacking this. This big block of foam fits snugly between internal components of the machine to keep them from rattling and shifting during shipment. But it's easily removed, so internal components can move freely. With the main block of foam removed, I can ease the gantry forward and pull out a secondary block at the back of the machine that protects one of 2 internal cameras. And with that internal foam removed, you can see that there's more layers of material down in the bottom of the machine, but those get removed by pulling out the base plate tray from under the machine. And that fact puts me in a bit of a predicament because I learned that there's a little issue with my portable cart design in that the feet slip down into the bottom of a 1-inch tube, and that lowers the whole machine enough that there's not enough space underneath here to access the tray. So I've got to modify the cart a little bit so that the machine sits higher and that tray is accessible. So I'm going to get to work on that and show you the result of that fix next. Luckily, the fix for my little predicament is more embarrassing than it is difficult. First, I came up with a piece of gray PVC pipe that has a nice fit around the feet on the underside of the P2. It's a good fit with just a little bit of play, so the laser will drop into place without a fight. To increase the size of the holes on the support tubes from the size I drilled originally to one that's big enough for this PVC pipe to slip into, I just made a drilling guide block that fits the PVC pipe and can be clamped on top of the tube to rebore the hole without any metal in the middle to guide the pilot bit of the hole saw. With the drilling guide block clamped firmly in place and a sharp hole saw chucked up in my Makita cordless drill, I use a good dose of cutting oil and carefully but quickly enlarge the size of the hole in the support tube. And after a minute or so of sweat and smoke, I've managed to cut a thin ring of steel out of the top of this tube to enlarge the size of the hole so that the PVC leg support pipe drops in with a clean, easy fit. And luckily, as I said, the fix is more embarrassing than difficult, and it doesn't take long to resize all 4 holes for the leg supports. To raise the laser above the cart, the full 1 1/8" height of the feet on the machine, I cut 4 pieces of that gray PVC tubing to 2 1/8 inches, which compensates for the 1-inch depth of the support tubes. As I'm finishing up this modification, I want to remind viewers that this whole cart is a one-off prototype, and as such, ask for a little bit of grace, because even as I'm finishing up the repair, it dawns on me that a better design would be to tack weld a little piece of steel pipe on top of the support cross tubes for the feet to drop into. It'd be just as secure, a lot cleaner, and a lot simpler, because all this extra drilling isn't required, and the placement of the machine on the cart would be just as secure, if not a little more so. As is the case with so many prototype projects, I use the process of failing forward to figure out new, quicker, easier, better ways to do things. And this is an example where I decided to use a couple of smooth, solid wood rails to transfer the laser from the lift to the cart, slide it into position, and then simply remove the rail to lower the laser into the leg support pipes. And that simple bit of what I call Egyptian engineering allows me to transfer the laser unit, which is right around 100 pounds, onto the mobile base, all by my lonesome, without strain or sweat. Completing that inevitable but somewhat frustrating and embarrassing sidebar brings me right back around to where I was just a short time ago, where I remove a small screw from inside the machine that holds the tray in place so that I can finally remove the tray and the last bit of packing from inside the laser. And now, finally, I can get back to the regularly scheduled broadcast where I can show you this laser in operation, like I promised, before I got off on this rabbit trail of the final unboxing and unpacking of the machine. Since this is my first meaningful experience using a laser that's capable of engraving and cutting, I did some experimenting so that you can see the P2 at work, instead of showing you countless hours of me bumbling around, figuring out all the little things necessary to actually use the software and run the machine in a productive way. After about a week of trial and error using the P2, I've still got tons to learn about the software, but I want to show you 4 project examples to show you that it is possible to set up and use this machine without an advanced degree in CNC laser operation. That is, providing you know a handful of small but very important details. For a glimpse into the wide range of projects that this 55-watt P2 laser is capable of, I'll demonstrate with 4 example projects. First, I'll show how to set up and engrave basic text like I did for this sample banner on this Master Carpenter's tool tote that I'm building and filming for an upcoming masterclass video, where you'll see the results of the laser at work when I engrave that banner into the actual side piece of the Master Carpenter's tool tote, when I decide what font, what size, and what settings to use to engrave that banner into the fiddleback maple that I used for the accent stripe on this tool tote. Next, I'll show that it's possible to import and engrave a signature image that I'll use to customize the end of the Master Carpenter's tool tote with my actual signature to personalize the project. After that, I'll walk you through the process that I used to scale down the same signature image for my Next Level Carpentry pencils and combine it with a bitmap image of my Next Level Carpentry tool tote logo, plus a scaled down version of the Next Level Carpentry text, to give you an idea of the versatility of the P2 for projects big and small. I'll finish up with another cool project that also involves engraving, but adds the extra capability of cutting, where I set up, engrave, and cut out a pair of my professional carpenter push sticks in a process that I find pretty cool. But before I start those 4 projects, I'll cover the extremely important facts that I mentioned earlier. The first thing you should know is that the P2 requires software running on a device with an operating system to function. I'm using a Microsoft Surface Pro here, and a USB cable is included to connect the machine to your device. And while you might think that this is a straightforward thing, I actually found it a daunting hurdle. Let me explain. The P2 has a USB-C port on the lower left front corner of the machine, and the supplied cable is USB-C to USB-A. My Surface Pro 9 comes with two USB-C ports, but no port for a USB-A connector. To an old school carpenter contractor like me, the obvious solution is to buy a dedicated USB-C to USB-C cable to connect the laser to the laptop to make a clean, seamless connection between the machine and the device versus one that requires an adapter to splice the cables together. Makes perfect sense, right? Wrong, and far more wrong than I ever imagined. Not only was my thinking wrong, but it's so wrong that I can't believe xTool doesn't put a warning notice on the outside of the box explaining just how wrong my practical thinking is. You're probably not going to believe this, but after 4 days of racking my brain, challenging Eric, my tech consultant, and working with tech support at xTool, I learned the only functional way to connect the laser to the laptop is with a decidedly low-tech, inefficient, and illogical, but thankfully inexpensive USB-A to USB-C adapter like this. That's just like telling a carpenter it's better to use a 3-foot extension cord to extend a 22-foot extension cord than it is to use a 25-foot extension cord in the first place. Good grief. Apparently, I waded into a very high-tech quagmire that has to do with USB-C cable standards and protocols, that has something to do with host peripheral device communication standards, and power flow direction between two devices. Go figure. If you want further proof of just how deep this quagmire is, you should know that it's a violation of the first order if you plug the adapter into the P2 and the cable into your laptop. No, no, no. You must plug the cable into the P2 and the adapter into the USB-C port on your laptop. And who knew that a digital troglodyte like me is expected to know this stuff when it took tech support at xTool 3 days to offer a solution? Well, I hope the takeaway from all this is that you benefit from my exasperation because now you know all this USB-S and shouldn't have any trouble getting your laptop and your P2 to communicate with each other. And you can thank me later. Other important but more obvious things are that software is required to run the laser. So for this video, I chose to download and install Creative Space, the dedicated program xTool offers for use with their line of lasers. After poking around with the program for about a week, I find Creative Space fairly intuitive, functional, and capable. Other software options besides Creative Space are Lightburn and Laser Gerbil, and both of those are third-party programs that do most, but not all of what Creative Space does, plus a bunch of other functions that I don't profess to comprehend. The only controls on the P2 are the on-off toggle switch on the back of the machine and a large start button on the top. Oh yeah, I should mention about the large emergency stop button that's also located in the back right corner of the machine. Perhaps the most important step of all is to connect the power cord to a live 120 volt receptacle. And you want to pay close attention here because, like the USB cable, protocol is very important. It's essential that you choose a receptacle that's not less than 12 inches and doesn't exceed 48 inches off the finished floor of your workspace. Plug the business end of a UL-approved 3-prong extension cord into the lower outlet of said receptacle using your right hand, but only after confirming the ground prong is in the bottom position. Coil any extra cord length on a concrete floor in a counterclockwise loop not smaller than 20 inches in diameter. Plug a tri-tap adapter into the extension cord and finish up by holding the plug with your dominant hand and inserting it into the right side of the tri-tap, making sure the ground prong of the plug is facing skyward. After all, in this day of high-tech and innovation, it would be ridiculous to think it necessary to worry about which of 3 plug-in options to use, right? Got it? Got it. Just kidding, of course. Other basic but essential things include following instructions in the manual for filling the laser tube with antifreeze and aligning mirrors for the laser beam. Last but not least, attach the exhaust pipe to the port on the back of the machine and route it outside because the 55-watt laser beam generates some serious smoke when working with wood. With everything hooked up and set up, the first demonstration I'm going to show you is creating and engraving basic text. Because I need to do this for an upcoming masterclass video where I show in depth how to build my Master Carpenter's tool totes. It's a perfect example of how I intend to use this P2 laser on actual carpentry projects here in the Next Level Carpentry shop. As I dive into this, I want to tell you that reviews and tutorials only go so far in teaching you how to operate a laser like this. So I recommend just jumping into the deep end to figure out how to tread water with it, like I did. With the laser turned on, I put a piece of S-crap plywood with the contour of the side of the tool tote drawn onto it, onto the slats in the working area of the laser, and use the 4 spring-loaded hold-down clamps that come with the laser to hold the piece flat and secure for engraving. And because I want to make it easy on myself, because nobody's going to do it for me, I make sure the workpiece is parallel to the back of the machine by setting it at an arbitrary but even 3 inches from the back panel in the work area. With the laser connected to my Surface Pro 9, I launch Creative Space and refresh the screen capture so it shows the piece I'll engrave. This feature of the P2 is, hands down, my favorite because it provides a true WYSIWYG image so I don't have to worry about setting coordinates for engraving. Next, I select the text tool, type in Next Level Carpentry, select the font, set font features, drag the font onto the workpiece, and adjust its size to fit the space for the banner on the side of the tool tote. Once those initial choices are made, I select the banner text and define the properties for engraving. Because I've got so little experience using the P2 to draw on, at this point these selections are little more than a wild guess. But once those selections are made, the next step is to determine the thickness of the material I'm engraving. And once again, the P2 makes this step effortless. I simply select the thickness measuring option, tell the P2 where I want it to measure, and it automatically goes to that spot, measures the thickness, and stores it in memory for use during the engraving process. Just as quickly, accurately, and painlessly as that. Once I've gone through those steps, I hit Start to tell Creative Space that I want to engrave this text on the material that's on the laser bed. It takes a second to process, and a screen pops up that shows me basically what the engraving is going to look like. Hitting the next Start button lets me know I'm getting really close to launching the actual engraving process. So I close the lid, hit the Start button that really means business, and the laser gantry springs to life and goes about engraving the banner logo that I programmed it to do. The relatively high power and low speed settings that I chose means that this particular engraving is going to take some minutes to do, but it should come out dark and deep like I want for the banner on the side of the Master Carpenter's tool tote. I chose a fairly high number of lines per centimeter for this particular engraving, which gives the letters a consistent dark appearance. By changing the settings for faster speed, lower power, and fewer lines per inch, I can get an entirely different effect in the appearance of the letters, so choices for the appearance of this text are nearly unlimited. The exhaust fan in the laser chamber does a great job of removing smoke that's generated by the CO2 laser beam as it burns away layers of veneer on this thin piece of scrap plywood. And as you might expect, an effective exhaust system like this is an absolute necessity when working within the confines of a shop. Once the engraving process is complete, the laser head parks itself at X0, Y0, and the software keeps the lid locked for 15 seconds or so while it clears out the last of the smoke generated by burning wood with a laser beam. With the settings I chose and the size of this project, that burn took about 10 minutes, and I think you'll be impressed, as I am, with the results that I got. The engraving is nice and deep, it's got good rich color, and collateral damage in the way of scorched wood around the engraving is pretty minimal. And that scorched wood collateral damage is quickly removed with sharp 150 grit sandpaper on a stiff sanding block. And when I follow up with a gentle breeze of compressed air, you can see the final result I got with this engraving. And to me, that's what the diving in process looks like, because each material engraves a little different. Each setting affects the final look of the engraving. So I've got some work to do before I commit to engraving this piece of maple that's built into the toolbox because I've got so much time invested in it. But it's simple enough to do, to set up and to experiment, to minimize the wild cards that'll show up before engraving a one-of-a-kind piece like the side of this tool tote. But now that you have an overview of how some of the setup and operation looks, I'm going to shift gears and give you an overview of the process I used for engraving my signature in this piece of scrap material. First gear of the project for putting my actual signature on the end of the tool tote is pretty much the same gear as engraving the Next Level Carpentry text as a banner on the side of the tool tote. I've got a piece of scrap plywood clamped down to the slats in the laser, and to make my life easier, I've got a spacer bar at the back of the machine to hold the piece parallel, and I traced the outline of the end of the tool tote and added a center line. And while these measures aren't necessary because the laser can align the text no matter what the position of the plywood is, I found that it's just quicker and more efficient to use analog steps for alignment than it is to use strictly digital measures. I have Creative Space open on the Surface tablet, and you can see the image of that piece of scrap plywood clearly on the screen. Because I'm using my actual signature and not a TrueType font, the process for adding the signature involves importing a file that I created earlier. So I use the Import Image option under File and import that signature, where you can see it pops up on the screen. Because this signature is a screen capture, it has a white background that I don't want to engrave. So I want to edit the image and remove that. So I use that Edit Image selection and then tap the various areas to remove that white background. And I use the Zoom tool to help out because there's some little areas here that need to be cleaned up. And when I click Save, I can see what I've done, and I've still got one little bit of background right here. So let me do this edit again and take that out. And that should do it. And now you can see the text is clean, and it's bigger than I want it to be, so I'm going to scale it down using a handle here. And I want to rotate it 90 degrees, which is just as simple as that. Still a little too big. I'm just shifting and positioning that with that image selected. I can use arrow keys on the surface to move it around incrementally. And I just shift it around till I like the way it looks, the way it fits on the end of the tool tote. I kind of like that. And to make it look a little more natural, I'm going to use one more option here, and I'm going to rotate it up here. And I already checked this out. I'm going to go -3 degrees. Oops, -2 degrees. And you can see the image shift. And with those simple steps, this is the image I'm going to get engraved on the end of the tool tote. So I select that geometry, and I don't really know what the sharpness and the grayscale selections do. We want it as sharp as can be, I think. I'm not sure what the grayscale does. But over here, the only option I have is to engrave, because this is a bitmap and not a vector file. That's some complicated stuff that comes up in this laser business. But I'm going to jack the power up to 90 and put the speed at 250. And now there's a bitmap mode selection here. I don't really know what these do. I'm just going to leave it on Jarvis. And then the lines per inch, because I want this to go fairly quickly, I'm going to scale this to 50 lines per centimeter, not per inch. And I'm engraving, that's a bi-directional engraving. So I've got all that stuff set up like I want it. And again, because I've not done so much of this, this is a little bit of a hip shot. I'm going to zoom in here once. And I can see some fuzziness around the edge of this image. So I'm going to see if I can take that out of there with the grayscale slider. That looks better. That little hazy white edge went away. And I'm liking what I'm seeing there with the layout. So I'm ready to start hitting start buttons. And I'll start with this start button, starting now. And it tells me that I forgot to measure the thickness, which I'll do. I want to measure right there. And the machine went and did that process. Tells me that this is about 1/8 of an inch thick, and I'm all happy. Now I can start starting the start buttons, starting with this one. And if you look closely at this, you can see that this is somewhat gray. If I change the settings to more heat and slower speed, that'll actually darken up if I add more lines per inch. So the grayscale of this image gives an idea of how dark the image is actually going to be on the plywood. So let me hit this start button to get one step closer to business. I mentioned earlier that I've been playing with this for about a week, and I've got a lot to learn, but one thing I did learn is what I'd call a finer point of engraving time setup. And the way this is the sample I did before. It goes on the tool tote, and the end of the tool tote is too tall to fit in the machine. Doesn't quite fit in there. So I've got to engrave the piece this way, or I could use the depth feature, take the tray out, and put this piece underneath the machine so that it can engrave back and forth. And the reason that makes a difference is because I had the lines per centimeter setting, and those lines are going across. So if I have an image in this way, I can divide this, figure out how many centimeters that is, divided by 50, that's how many passes the machine has to take to engrave it. But if I turn the image this way, lines are going to go this way, and I'd only be dividing this distance by the 50 lines per centimeter, and you can see that it would go a lot quicker. But for the purposes of this video, I'm just going to do it sideways because I can use the fast forward thing to keep this from being so boring. But needless to say, when the laser is engraving this long tail here, it takes quite a bit of time to engrave that 2 or so inches, where if it was this way, there'd probably be only 10 passes instead of 150. But that's why I've got it set up this way. xTool does make a riser base for this machine, and they also make a pass-through conveyor. So if a person was doing a lot of tool tote ends, it would probably behoove one to get one of those setups, because the engraving of this particular text on this particular piece would be a lot quicker. But as it is, I just want to show you how cool this is, and I'm going to do that right now with a firm press of the start button. I don't know if I got it on the camera or not, but there's a slight pinprick of light underneath the laser head as it goes back and forth, and that's the invisible CO2 laser beam basically burning thin layers of wood. And so the light is actually a flame and not light waves of a laser beam. I don't know the technical differences between a CO2 laser and a diode laser, but the thing I do know is that the CO2 laser beam is invisible, where the diode laser has a different type of beam, and you need to wear protective glasses if you look at the engraving process in action. I mentioned earlier that this signature is a bitmap image, so the P2 can only engrave that type of file format. If I was actually cutting these letters out or scoring them, I would need to convert it to a vector file, which I'll do later for the Pushsticks. But for now, suffice it to say that the type of file matters depending on the type of output you're working towards. Call me crazy, but I took the back cover off the machine so you can see what the laser tube looks like during the engraving process. The laser tube itself is a very futuristic looking device with a coiled glass tube and a long straight tube housed in a larger tube, with antifreeze being pumped through the center tube. And at the downstream end of the tube, the laser beam gets deflected around a cone of some sort before it exits the laser tube and hits the first mirror on the way to the engraving process. As the engraving process gets to the long tail of my signature, you can see the monotonous busy work that the gantry and the laser head have to do to draw that long line by going side to side instead of lengthwise. You can see on the end screen that engraving took 7 minutes and 41 seconds with the settings and parameters I outlined for the burn. So I'll back out of that screen, and because this is getting pretty close to the end result I want on the finished tool totes, I'll save the file so I can come back to it later and reuse all the settings. After the last of the smoke is cleared from the chamber, I can open the oven and see the results that this particular recipe produced. And I like that quite a bit. I might go with a little slower speed to make this a little bit darker in the final estimation, but I do like the fact that I rotated that signature. This one was running straight with the world, but I like that negative 2 or 3 degree tilt. Gives it a little more hand-drawn effect. And you can see there, for all practical purposes, what this signature is going to look like when I engrave it on the actual end of this Master Carpenter's tool tote. When I've got a little more experience and I'm a little more confident of the results and the process I'm using. And figuring out those variables is the art part of this, where running the program itself is probably the science part. Oh yeah, I'll buy that. And keep in mind that engravings like this only become more bold and more vivid once a finish is applied. As you can see here, when I mixed this example with alcohol to make the signature really pop. And now, as promised, I'm going to tackle the pencil engraving project next. And because I like the work I did on the signature bitmap for this project, I'm going to use that same image, but scale it down so it fits like I want it on these pencils. And it's important to mention that the P2 has a feature called Smart Fill, where I could literally just scatter these pencils around on the slats in the laser, add the text and logo to one pencil, and it'll seek out all the other pencils no matter where they're laying, and add the text oriented the same way. And that's kind of a little bit in theory. These pencils are shiny, they have beveled edges, and because there must be some parallax in the camera, it's a little tricky to get that all to work out. So I made this special little board. This is just MDF. And I dadoed slots in here that are the exact width of the pencil, and these pencils are exactly 1 inch apart. I spaced them that way for the layout in creative space. And one other thing about the Smart Fill feature of the laser is that there's a pretty decent air assist going on, so when the laser's burning, there's air blowing. And the first time I tried to do the pencils just scattered on the bed, the air just blew them around. So I'd need to tape those pencils down or clamp them down somehow anyways. So I spent the time to make this little fixture for holding the pencils. And so far, that was time well spent because this setup works really slick. It's no coincidence that I made this block the exact width of this work area here. So when I drop it down in, I just bump it against the back of the machine. All these pencils are perfectly parallel, and it's real easy to adjust for where this is going side to side as long as it's straight in here like this. And once I have the pencil fixture set up, I just hit refresh and the camera captures what it's looking at inside the laser. And now you can see all the pencils arrayed there and then this large signature from the last project. But because I want to start a new file for this, I am just going to do a file save as. And I'll title this Carpenter Pencils for the YouTube video. And now you can see this has been resaved, and I can manipulate this signature so that it works on the pencils. And the first thing I'm going to do is unrotate it like that, and now I can rotate it again 90 degrees. And this way I don't have to go back through the gears to get that signature cleaned up for use on this project. And here I'm using the hand and select tools to resize and reposition that signature until it's where I want it located on the pencil. And for this project, I'm going to do one more thing and introduce layers and put the signature on a purple layer. And that'll help keep things organized later when I adjust settings for the engraving. Once the signature is sized and placed, I'll use the text tool to enter the Next Level Carpentry text that'll get engraved into this pencil. And once I've misspelled the text, I'll adjust the parameters so it fits on the side of the pencil the way I want it. Because I don't have that much experience with the program, it takes me a while of fussing and fiddling to adjust the size of the text so it fits the way I want it and get it positioned on the pencil approximately where it'll end up in the final engraving. Once I've gone through those steps, I'll select the text and put it on its own layer for this file. And I arbitrarily select the green layer so that it lives within its own space within the file, but is distinct from the signature itself on the purple layer. Once those steps are complete, I'll take another lap around the same mountain by importing another file, which is the Master Carpenter's Tool Tote logo that I want to add to the engraving on the pencil. When I select it, you can't see it because the image is zoomed in way too far. So I'll back out and bring it in to work on it with the other elements for this engraving. And while it's selected here, I'll add it to its own layer because it seems to make things easier working with various elements on the same project. And one advantage of having these separate items on separate layers is that it makes it easier to select small items without altering their shape or position, which is all too easy to do using the regular drag and click selection method. Now that all three elements are positioned approximately where I want them on the pencil, I'll use another tool to dial in the alignment so the arrangement is pleasing to the eye. I do that by selecting all three items and using the Align tool to line up their centers horizontally. And as I did that, you can see the text jump into alignment with the toolbox and the signature, so they line up just right. And the final step is to go back to the Align menu and select Distribute Horizontally to quickly get the spacing more even than I can do it by eye. And because each item is on its own layer, The P2 engraves them one at a time on the face of the pencil, using the settings I have for each one independently. First up is the little tool tote logo, and it burns that in quickly before moving on to engraving the text, which, if you remember, I set with fewer lines per centimeter for a more grainy look, which it completes before finishing up with my signature. And as you can see, the logo and signature came out fine, but the text is far too light. So I'll go back to the software, adjust the settings, and burn it again to darken it up. And this extra step also highlights the extreme precision of this machine, because there's no blurring of text, regardless of the number of passes it takes to engrave it. And this is the exact reason why I like having the different elements on different layers, because I can tell the software to ignore the layers that are fine, so that I'm just editing and re-engraving the element that needs adjusting. And that looks like mission accomplished to me. Because the pencil is lacquered, smoke from the engraving tarnished the lacquer a little bit, but it's easy to remove that collateral damage with a little bit of denatured alcohol on a tissue. And that gives you a pretty good idea what a nicely engraved misspelled word looks like. In the spirit of not taking myself too seriously, I'm going to select all three items, group them together, and copy them onto a couple more pencils, and burn a few more of them for the sake of the video. And by using the magic of the software, I've shifted, adjusted, aligned, and arranged the engraving for 4 of these pencils so I can burn them to wrap up this section of the video. And here again, the layers feature helps me to correct a mistake I made where the orange and purple layers were going to be ignored, because I can select the layer and batch edit everything that's in it so the engraving comes out as intended. Yeah, that's what I'm after, right there. It's fun to watch the layer tackle the engraving in layers, completing first the logos, then the text, then the signatures in sequence. And even though I can use fast forward, I'm leaving this whole segment in here because it's insight into the reality of laser engraving, which always includes a session of fiddling with the software, getting things set up, and then an inevitable thumb twiddling session while the laser works its magic and engraves as instructed. And I think the repetitive precision of this machine is one of its most amazing attributes, as it goes about engraving a high level of detail without one word of complaint. Looks like mission accomplished to me. And the software says it takes 1 minute and 3 seconds to engrave a pencil. And as before, the last step is a quick wipe with some alcohol to remove the tarnish on the varnish on the pencils. And with that, I can wrap up this segment of the video by saving the file for future use and shutting down the machine as I segue into the final segment of this video, which is to build on what you've already seen in the video and add cutting to it as I set up, lay out, engrave, and cut out some of these professional carpenters' push sticks. And you've probably noticed other ones on the wall back here. I've made those in a previous video doing them manually, but I think this project is a pretty good crossover transition between manual and CNC laser work and highlights another capability of the P2 laser. And even though this is a basic, very simple entry-level project, I think it'll open your eyes to some of the possibilities and capabilities of the P2 desktop laser by xTool. As with every project, I start out with a piece of material on the laser bed. In this case, it's a piece of 1/4 inch MDF with white melamine facing on it, and it's big enough for a pair of nested push sticks. I need to jump in here with a brief explanation of how I came up with the profile for these push sticks. It would take a whole video to walk you through all the steps, but basically, I took a photo of one of my actual push sticks, imported it into Trimble SketchUp, and traced around the image to create the shape, using arc and line tools available in the software. After separating the shape from the photo, I then exported the shape out of SketchUp and imported the image into Creative Space. Next, I used editing tools in the software on the image to remove the white background and use the outline tool to convert it from a bitmap file to a vector file, which is what you see me working with in this segment of the video. Easy peasy, right? Not. But at least now you know that it's possible to import an image and determine the file type for use on your projects. As you can see, I've got the previous file opened up here in Creative Space, and the screenshot shows the piece of white melamine I just put on the laser bed. It's in a little different position than the last time I ran the file, but all I need to do is reposition the push stick outlines so they fit on that piece of material. A closer look at this particular screen shows the 3 layers that I have. And in this case, the red layer is the push sticks, the green layer is the engraved text, and the purple layer is just a note I added to remind me of what it takes to cut this out. And I chose ignore for the node itself, so that only shows up on this screen, but doesn't get burned into the project. But it tells me I need 100% power and a speed of 15 with 2 passes to actually cut out the push sticks. But to engrave the text, I've got the power set at 50 and the speed at 300, with 60 lines per centimeter, providing dark enough text so that it's clearly visible on the push sticks. So you can see once again how I'm using layers to organize and execute a project. Another feature of the software that I'm learning to use on this project is the canvas tabs you see at the bottom of the screen. And I'm using a second tab for this project to engrave text on the other side of the push sticks after they've been cut out. But for now, everything's set up this time like it was last time, so I feel fairly confident that the engraving and cutting will be successful. And the preview image clues me in that I had one of the layers set to ignore, so I just go back to the settings and correct that before proceeding with the start sequence. This time, pushing start initiates the engraving process, which the P2 completes for both push sticks before advancing to the cutout sequence in 2 passes. It seems to me that melamine is a pretty tough surface, so I use a slow speed and a relatively high power to burn the text into the melamine so that it's visible on these push sticks in use. From this angle, you can see the small bright flame generated by the laser beam as it hits that melamine, which to me is kind of mesmerizing and makes an otherwise mundane process fascinating, if you ask me. A glance at the software screen tells me it took 2 minutes and 45 seconds to engrave that text onto these 2 push sticks. And once complete, the laser switches from engraving to cutting and sets about making 2 slow speed passes around the push sticks to cut them free from the sheet they started out in. Time and experience will tell more, but at this stage, it seems like 2 faster, lower power passes are better than 1 really slow, hot one, because the heat generated by the laser beam is less likely to ignite the piece while trying to cut through it in 1 pass. And a quick check tells me that the push sticks aren't completely cut out yet, so I'll adjust the settings so that it ignores the engraving part and redoes the cutting part to free up the push sticks from the piece. And as I reset the settings, I notice I had this set for 1 pass, even though my node instructed 2 passes. But that's no big deal. I just ignored the engraving, double check the speed and power, and hit start to run that second pass for cutting out the push sticks. On this pass, I noticed more smoke coming out from underneath the piece than I did last time, which indicates that it's probably cutting all the way through, although I won't know for sure until the pass is complete. Now comes the moment of truth. Oh yeah, there we go. 1 professional push stick, cut out of a piece of melamine-faced 1/4 inch MDF, just like that. There may well be a more efficient way of going about this, but this worked before, so all I do is flip the piece over and use the small spring clamps to hold it down to the slats so it doesn't move while being engraved. Now, after closing the lid, I switch to Canvas 2, refresh the screen image, and reposition the text that gets engraved on the opposite side of these push sticks. I reposition the outline of the push sticks, which is the purple layer, but it doesn't matter because that's set to ignore. But I realign the text to the photo that shows the actual cutout of the push sticks on the laser bed. And after double checking the settings, go through the start sequence to engrave this saying on the opposite face of the push sticks. More experienced users might be shaking their head at the sequence and process I used for engraving text on the opposite side of these push sticks, because there's potential for errors and inconsistencies on details that I've not learned yet. But because it's just a line of text, the exact position isn't that important. And in a production setting, I'm sure there's measures that could be taken so that positioning and alignment matches the level that the laser is capable of. But nevertheless, it took just 2 minutes and 48 seconds to engrave the line of text on the opposite face of the push sticks. And as before, a spritz of alcohol and a paper towel is all it takes to remove the smoke and soot from these push sticks and clean them up so that they're respectable enough to use. Even though I barely scratched the surface, or should I say barely engraved the surface of this machine's capabilities, this has got to be the longest unbox and review video for this laser on YouTube. But what did you expect when a digital troglodyte like me unboxes a decidedly high-tech device like xTool's P2 desktop laser? And I didn't even get into the rotisserie engraving attachment in this box. This amazing RA2 Rotary Attachment 2 Pro opens up a whole other level of possible engraving projects for cylindrical objects and would probably nearly double the length of this video, so I'm going to skip it for now. For the same reason, I only mentioned that there's a height attachment and conveyor accessory available. Two more accessories that, along with the autofill feature I mentioned in the video, expand the P2's advanced production capabilities exponentially. I'll wrap up with my overall thoughts and impressions from my experience when Old School met xTool. I was impressed from the beginning with this machine's fit, finish, and features, which motivated me to design and build the custom cart for it. So you can imagine my frustrated reaction to the USB BS I experienced with the dysfunctional USB cable situation when I went to hook it up. To their credit, tech support at xTool was attentive to the connection problem I experienced, and I hope they take it to heart and make other users aware of the obscure but simple fix, because without it, the P2 is a very expensive yet ineffective boat anchor. I really do enjoy the challenge of entering a whole new paradigm and putting this P2 desktop laser to work. But in truth, if I weren't a certified YouTube diva presented with the offer of a free laser to test drive, I wouldn't have dropped over 4K just to engrave branding on a few projects in the Next Level Carpentry shop. If, on the other hand, I decided to add laser capabilities to my resume or to build out a laser engraving / fabrication business, based on my experience with this machine so far, I'd be more than comfortable investing in this machine, confident that it would quickly pay for itself and could do all I expect of it and more. So if you happen to be in the market for a Next Level CO2 laser, I encourage you to put this one at the top of your list of considerations. And if you decide to pull the trigger on one, you can follow links in this video's description for a discount on xTool products purchased through Next Level Carpentry. Sales through those links will pay a small commission to the channel, so I'll thank you in advance. Even if you just browse xTool's website, you'd be returning a favor by mentioning that you saw this review here on the Next Level Carpentry channel. So I'll leave you with all that and say, as always, and until next time, thanks for watching. Wait, what? You watched that entire video about this 55 watt CO2 laser and you're not burnt out yet? Cool. I like your style. Attentive viewers like you probably noticed that in the video's thumbnail and in a few scenes during the video, you can see the Next Level Carpentry Tool Tote logo and Next Level Carpentry text as a banner on the front panel of the cart that I made early in the video. I created that element to serve as branding for the channel and the video using steps shown in the video. So, if you're both attentive and curious, here's a quick overview of how it was made. First, I imported a bitmap file of the Tool Tote logo along with the text in Altivo Bold, the official font of Next Level Carpentry, into Creative Space, adjusted engraving and cutting parameters, and then spent about 23 minutes engraving and cutting out the logo and letters, as you see here. Next, after sanding away collateral damage soot from the letters and logo, I sprayed all the puzzle pieces with a couple coats of clear rattle can lacquer to enhance the color and lock in the wood-burned brown color. After that, I went through the tedious process of applying spec tape, double stick tape, to the back of each piece using scissors and knife to trim it to fit. Note to self, in the future, apply double stick tape to the back of the thin plywood before cutting out the letters, because the P2 can cut that tape and eliminate this monotonous step without breaking a sweat. Next, I clamped the cutout plywood piece to the front panel of the cart to use as the perfect template for placement of the logo and letters. Then, like a kindergartner with a puzzle, placed each letter into its designated spot and pressed it to stick it permanently into place. Once all the letters were precisely placed, I simply unclamped and removed the cutout template and used a rubber roller to apply firm pressure to all the letters so they're stuck firmly in place. And thanks to a bit of experience and excellent performance from the P2 laser, that was the end of that. And this is the official end of the end of the end of this video. Thanks for watching.